Let's take a look at section 4.2, reflections. Sounds pretty easy. You should know what a reflection is. Maybe you've looked at a mirror and you saw what was, on the other side. It happened to be yourself. Or at a lake, you had a tree, and then you look on the water. Hey, you see that tree again. That would be considered a reflection. Right, so our official definition is a transformation that uses a line like a mirror to reflect a figure. So let's go ahead right here. If you look at the at your screen, there's a line right here, and that will represent my line of reflection. And over here to the left, let me go ahead and draw a triangle. And let me go ahead and call this triangle X, Y, and Z. So if I were to reflect this across the line of reflection there, then it would look something like this. On the other side. And my point would be, now this one would be X prime. We have Y prime over here, and Z prime down there. Don't forget, we call this in blue the pre-image. We have this over here in red, the image. All right. Let's go ahead and take a look at our next term, glide reflection. In glide reflection, think about it. If you're gliding on ice, you're taking something and you're moving it. And when it comes to glide reflection, not only are you there is translation first, where something's moving left, right, up, or down. And then after that, you're going to reflect it. And that's the idea of glide reflection. Translation first, then a reflection. Okay? Let's take a look next at line of symmetry. Let's say I have right here, we got ourselves a square. And in this square, I want to figure out how many times can I draw a line through it to where it reflects. So if I were to fold over the line, it would fold over itself. So if this is a square, I could draw one line right here. That would be one. Right? If I were to fold it over, it would overlap. I could draw a horizontal line. That would be another. I could draw one that goes diagonally. It would fold over in itself. And then the last one right here, going over through the next diagonal. And so we would have right here 4 lines of symmetry. Okay. That's your idea of line of symmetry. Figure out how many times can I draw a line that goes through a polygon or a figure. It could even be letters. You'll see in the homework. And to be able to, if you fold it over, will it fold over itself? Let's go ahead and move on down. So line of symmetry, a line that cuts a figure in half. Look at here, I got a square that I could have used to have done the diagram or the explanation. All right, let's take a look right here. A reflection, once again, a transformation that uses a line like a mirror to reflect the figure. And it's just showing you where this line of reflection happens to be. Line M is the line of reflection. We have point P, and then we have P prime on the other side. Now, everything should be the same. Therefore, right here, you notice that it shows that it's equidistant to this line, congruent. Moving along. All right. So, right here, this is the big thing about reflection. We know what it is visually, but let's say if we're just given points, how do I know where this point is supposed to move without doing a bunch of drawings and graphing everything? Well, here are the rules, okay? So let's say we have AB and we're reflecting in the x-axis. Then its image point is A comma negative B. So let's start right here. Let's go ahead and say that our original point is at 1, 2. Okay, so let's just say it's at 1, 2. That's our original point. And I'll go ahead and put right here 1. I've got an axis here magically, and I'm going to go ahead and plot that point. That right there is our original point. And so it says if we're going to reflect across the x-axis, which is that horizontal line, our point is now going to be at 1, comma, and then negative b, which would be negative 2. So then we have ourselves, that would be when it reflects across the x-axis. And let's see what happens. We got 1, negative 2 down here, and there you go. Okay? So that pretty much makes sense. It's equidistant, 2 units up, 2 units down from the x-axis, or our reflection. If we go right here, y-axis reflection, then they're saying that I'm going to take whatever my original value was. We remember this is, we have A and B. And we're going to take the opposite of A, so we have ourselves negative 1, comma, 2. And that right there would represent our y-axis reflection. Negative 1, comma, 2 up here, and that would be our y-axis reflection. You can see it. 1 unit to the left, 1 unit to the right of the y-axis. We move down right here to if A and B is reflected in the line y is equal to x. Now y is equal to x, don't forget that is a diagonal line. So let me go ahead right here. Y-intercept is 0, 0. We have ourselves that. And we're reflecting across this line. And this is y is equal to x. So let's see what happens. They're saying that, look, all of a sudden it's b comma a. So what we're doing is we're switching what x and y was, or a and b in this instance, and this is now going to be 2 comma 1. All right, so 1, 2, comma 1. There you have it. There is your y is equal to x reflection, and it's across this line. The last one right here is they have, well, when y is equal to negative x, and that's going to be going a line that goes down one to the right one. It'll do something like this right here. And then they're saying it's going to be negative b, negative a. So not only do we take 2 comma 1, but then I'm going to take the opposite of it and put negative 2, negative 1. And so let's go right here, negative 2, negative 1 will be down here. And you can see, remember, this is our original. This is the new. Here's our pre-image. Okay? And this right here is reflecting across this y is equal to negative x. All right? So you have to remember these 4 different rules for the reflection. And that's pretty much it. Bottom line, make sure you know them. All right? .2, the reflection postulate. It says a reflection is a rigid motion. So once again, what is rigid motion? The angles stay the same and the lines stay the same, or the lengths stay the same no matter what we're doing, whether we're reflecting, okay, up, down, left, right, diagonally, and so on. All right, let's take a look right here at number 1. It says graph triangle ABC and its image after a reflection of the given line. All right, so we take a look. It says we have ourselves y-axis reflection. So we have our 3 points right here. We have a triangle because it's 3 points, A, B, and C. So let's go ahead and graph these. Looks like based on what we have, we got negative 1, 5. We could if we make it fit, it'll be a little bit off the grid. So there's A. We have -4, 4. We have B. And then -3, 1. Right there, there is C. So there is our pre-image. And so we're reflecting across the y-axis, so it should look like things are over here. And when we reflect across the y-axis, well, we have our rule. You should know what the rule is, and then that is going to be -b, -a. Or sorry, -a, comma b. Right? -a, comma b is our rule for the y-axis. So we have now a prime, okay? That right there is going to end up being +1, 5. B prime is going to be +4, 4. And C prime is going to be 3, 1. And so we have 1, 5 up here. There's A prime. Looks good. We have over here 1, 2, 3, 4, 4. There's B prime. All right, looks like it's pretty good. Equidistant to the other side, and then we got ourselves 1, 2, 3, 1. And there is C prime. And there's our reflected triangle. Everything looks pretty good to me, pretty straightforward. As long as you know what you were supposed to do and you know your rules, that should make things pretty easy. Now let's take a look next up at number 4, because I think 1, 2, and 3, they're all pretty easy, or 1 and 2, because there's a straight rule for it. But number 4 is a little bit more challenging, because this time we're actually reflecting across a line. It says right here, x is equal to -3. So let's first figure out, remember, this is a vertical line when it starts with x. So I'm going to go ahead and put 1, 2, 3, -3 is right here. I'm going to draw my line of reflection. So think about this. I am drawing right here a line of reflection, and it's reflecting across this line. Let's go ahead, start off, and figure out where our points are. So we have -2, 1, 2, 3. There's point A. B is at -2, 2. Right there. So there's B. And C is at 0, -2. I'm going crazy. We have -2, -2 is point B, which is going to be down here. And then we have C is at 0, -2 down here. And so there we have our triangle now. All right. So we're reflecting across this line. Then remember, the thing here is this. I have rules for when it's like the x-axis and y-axis, and y is equal to x and y is equal to -x. But otherwise, remember, a reflection is equidistant to both sides. So the easiest way for me to do this is just go ahead and start counting. Okay? What I'll figure out right here is this. Now, from the line of reflection, A is 1 unit to the right. A prime has to be 1 unit to the left. So that tells me that A prime right here, it's going to be -1, 2, 3, 4, and then up 3. There's A prime. Okay, we'll gotta do the same for B prime. It's 1 unit to the right of the line of reflection, then it's going to have to be 1 unit to the left of the line of reflection. So B prime, that's going to have to be -4, -2, right? 1, 2, 3, -4, down 1, 2. And then C prime right here, well, it's going to be 1, 2, 3 units to the right. It's going to be 1, 2, 3 units to the left. And there's C prime, and we have ourselves our reflection. And we're going to have to count things out right here. Remember, this is -3, our line of reflection. We got ourselves 3, this -4, -5, -6. negative 2. And there we have our line of reflection. Okay? Or our pre-image and image points. Next up, let's take a look at number 5. So remember, right here, y is equal to x. That is a line. That is the line with a slope or a y-intercept of 0 and a slope of 1. Looks something like that. You can count things out, but that's not really what I want you to do, because remember, we have a rule for this one, and then the rule is where we go ahead and just switch the points. Or remember, it's going to be B, comma, A. So it's helpful right here to figure out, well, what are our points to start off with? All right. So I'm going to go ahead and write down my points first to make things a little bit easier, right? So we have A is going to be at, looks like, negative 3, 2. B right here is at negative 1, 2. C is at negative 1, 4. And D is at negative 3, 4. So all we need to do to find the image points is switch things around. And so remember, A and B, B, A. So then we have 2, negative 3. B prime is going to be 2, negative 1. We switch that. C prime is 4, negative 1. And D prime is going to be 4, negative 3. So all we need to do, once again, right here is we switch things around with y is equal to A reflection. So let's plot our points. We got ourselves 2, negative 3. There's A prime. We have B prime is at 2, negative 1. C prime, we have 4, negative 1. And D prime, 4, negative 3. And so if you were to actually have this on a piece of paper and fold it across this line, then it would actually overlap each other perfectly. Okay? Don't forget, with number 6, in order to do this, you got to remember the rule. It's not only we switch things around, but we change the signs, and it's negative B, negative A. So if you were to go ahead and do this, don't forget you'd have to apply this rule right here where you switch and then take the opposite. All right, moving along. I think you could do that one on your own. Let's take a look at number 7. So we have 3 points here, J, K, and L. And it says you're going to translate and reflect. So we have to do multiple things here. We got multiple rules. And let's get this thing done. All right, so let's go ahead first off. Let's translate things. So they give us the translation. Let's take J and let's plug things in, and that'll be J prime, right? Well, when we translate, this will be the image. So it'll be J prime. We go ahead and take 3, 1, and we plug that in to our equation, right? So 3 minus 6, that's going to be negative 3. 1 minus 1, that'll be 0. So there's J prime. K prime, taking 4, 2, plugging it in here. 4 minus 6, we have negative 2. Then we take 2 minus 1, that's 1, there's your K prime. Lastly, we got L, plug it in. 1 minus 6, negative 5. 3 minus 1, 2. And there you have our translation. Now the next step right here is this. This is where students get things messed up. They decide, remember, what they want right here is 2 things. You translate, and then from the translation, you're going to reflect after that. So what I see here is this when students do this problem. They take the original pre-image points, J, K, L, they plug it into the translation. And then the second step is what they do is they take J, K, L again, and now they plug it and reflect it. That's not what they wanted. They want you to translate first, and now we're going to take these points, J, K, and L prime, and then we're going to reflect it, and we're going to say that we have J double prime. And that'll represent the reflection. So now we have y is equal to negative x, okay? And don't forget, the rule right here is negative b, negative a. So since we didn't do number 6, we're doing that actually right here on number 7, which works out quite nicely. And so we're plugging things in. And so I take a look right here at J prime. We're going to switch it. It's going to be 0, and then now positive 3, because there's no such thing as negative 0. We have K prime, double prime. We're going to switch. We're going to now have negative 1, positive 2, and L double prime is going to be negative 2, positive 5. So let's see. Let's show the entire, I guess, progression of things. We have our original points. Now I'm going to graph everything out right here. We got ourselves 3, 1. So let's go ahead, 3, 1. There's J. We have 4, 2. There's K. And then L is at 1, 3. So we've got this tiny little triangle right here, but we'll make it work. And what they're saying is, first off, we have translation. So I'll use these next points in blue. At negative 3, 0, this is J prime. And then we have at negative 2, 1, we have K prime. Let's see if we get that at the right spot. There we go. There's K prime. And then we have negative 5, positive 2 up here. And there's L prime. So there's our translation. So from this translation, we're going to reflect it across that line of y is equal to negative x. And then it'll end up at 0, 3. There's J double prime. We have negative 1, 2. Right there, there's K double prime. And then L double prime is negative 2, 5, which is up there. So it's going all over the place. But we've got it all taken care of now. All right. Next up, let's take a look at numbers 9, 10, 11, and 12. If you were to identify a line of symmetry, are there any with these words? Would you be able to split them in half in any way where they overlap each other? With number 9, there would be none. Take a look at number 10. There's one right here, splitting it right down the O. Number 11 with the word kid. There it is. Horizontal line right down the middle. Number 9 or number 12 with the word dock. There it is again, right down the middle. So there's some instances where it works out, there's others that it doesn't. And now, you now know how to deal with and look at reflections.